Hello, my math friends. We're going to continue with a new unit with rational expressions, and we're going to be solving equations that involve rational expressions. And I'm going to start this unit with a few, I wouldn't say basic, but comparatively basic examples of solving equations with rational expressions. And then we're going to get into some more complex equations, and then we're going to end with crazy word problems, like the traditional, stereotypical algebra word problems that end up with funny memes about them. But that's for later. That'll be the third lesson. There's only going to be 3 lessons in the unit, but they are kind of intense because we have this innate fear of fractions. And so we're going to try our best to alleviate those fears. So again, the previous unit was all about working with rational expressions, and we talked about multiplying and dividing and adding, subtracting, and common denominators and all that garbage. And we're going to tie that in to some previous lessons on solving equations that we used to do. And so before we get into these 3 questions, I want to do some background work. Okay, I want to do some background work. And so we're going to take a step back in time with a couple of notes. Okay, so let's take a look at how we used to solve equations with fractions to begin with. And I'm going to start with one equation. I'm actually going to solve it twice, so you can see 2 different approaches, because we did use 2 different approaches. So if we have this equation, you want to go ahead and copy that down. The whole goal is to find the solution set. Okay, what is the solution for that value for x that would make this a true statement? So we want the solution set, and there's 2 different ways we can approach it. The first way is that we can clear fractions. So this is what we worked with at the beginning of the very beginning of the year. Okay, so in challenge 2, this is like the first thing we did. We can clear fractions. Now, how do we clear fractions? Hopefully you already know that. We multiply everything by the denominator. But we have 3 different denominators. So there's a quick way to multiply everything by the least common denominator, but I don't want to worry about that. I want to worry about one step at a time. So if we're going to clear fractions by multiplying by the denominator, what we can do is multiply everything by the first denominator. The first denominator is 3. So we can multiply everything by 3. So we multiply all 3 things by 3 and see what would happen. Now, as we know from previous experiences and the previous unit, we can start canceling giant 1s. So in that first number, we now have a giant 1. 3 over 3 cancels. That leaves us with x. In the second number, we can't cancel anything, so we just multiply 3 times 1, and we have 3 over 4. And then the third number, again, we can't cancel anything, so we're just multiplying. 3 times 2 is 6. So we've only cleared 1 fraction. And just like we did in September, we can clear another fraction. We have another fraction. There's a denominator of 4, so we can now multiply everything by 4. And we multiply everything by 4, and again, we look for a giant 1. And so we have a 4 over 4. In that second number, we're going to have a giant 1. In the first number, we multiply x times 4. We get 4x. In the second number, we have a giant 1, and we can cancel that. That will leave us with 3. In the third number, we can't cancel anything, so we just multiply. 4 times 6 is 24, and we leave it over the 5. And again, just like in September, we're only multiplying the numerator because this is technically 4 over 1. 4 over 1, okay? So now we're still not done because we still have that crazy fraction, right? We have one more fraction, is 5. We can clear that, again, by multiplying everything by the denominator. Okay, so we multiply everything by the denominator and see if we have any giant 1s that we can cancel. So in our first number, 5 times 4x, 20x. Second number, 5 times 3, 15. Third number, a giant 1 that would cancel and leaves us with a 24. And so we have cleared fractions. And that is the first approach. We can clear all the fractions. So when we clear all the fractions, we have this line. Now we can use some pre-algebra concepts to find the solution set, solve for x. We first have to get rid of the plus 15, and we get rid of that by taking it away. So we subtract 15 on both sides, and then we have 20x equaling 9. Then we got to get rid of the 20. How? We divide both sides by 20. And so we have our solution set of x equals 9 over 20. So again, that is the first way. Remember what we did? We cleared fractions. So if that was confusing, now's a great time to pause, rewind, watch it again. because I do speak quickly. But that is only one way of approaching this example. Okay, there's another way of approaching this example, which is what we did in the previous unit. In the previous unit, what we did was we simplified first, right? We looked for common denominators, and then if we have a simplified fraction on the left-hand side and a simplified fraction on the right-hand side, we could then cross-multiply. And I'll show you that note momentarily. Okay, so we can approach it that way. We're going to simplify first, and then we'll cross-multiply. Okay, so how does simplification work? This, again, in the previous unit, we have to find common denominators. So if I'm looking at the left-hand side, I cannot add these because they don't have the same unit of measurement. We need to find a common denominator. So we can simplify that into one fraction. So we find the common denominator between 3 and 4. We should know that common denominator is going to be 12. Or we can multiply one number times 1 and another number times a different 1. Okay, seeing that this denominator is 3, this denominator is 4. 4 over 4 is 1. 3 over 3 is 1. So we multiply by our clever 1, and then we can work with it that way. Okay, so again, just like the entire previous unit. So we multiply by our clever 1, we'll get our common denominator. 4 times x is 4x. 1 times 3 is 3. 4 times 3 is 12. 4 times 3 is 12. Now we have a common denominator. We have now simplified. Okay, so this is the previous unit. We cannot add 4x and 3, so we leave it. We are now simplified. So what happens if we have simplified fractions on the left-hand side and the right-hand side? We can then cross-multiply. Okay, so now we're going to pause for a second. We're going to pause for a second, and then we're going to learn about what cross-multiplication is. Okay, so let's relearn some cross-multiplication. All right, so how does cross-multiplication work? So this is a note inside a note. How does cross-multiplication work? If you have two fractions equal to each other, okay, two equal proportions, if you will, we can solve this equation for x by cross-multiplying. So how does cross-multiplying work? Make sure first you understand we have one fraction on each side. That's an important note to remember. So how would that work? Well, we can cross-multiply. Now this is where you can show a whole bunch of different correct things. Here's where we can show a whole bunch of different correct things. One correct thing is when we multiply x times c, we get xc, and then we multiply a times b, we get ab, and we keep the equal sign in the middle. That is a correct thing. But what if you don't see the x times c first? What if you see something else, like the a times b first, and then the equal sign, and then the x times c? Fine, that is also correct. Okay, because you got to remember we're using the reflexive property of equality, or we can also use the commutative property of multiplication, right? So multiplying can work in either direction. So all these different correct ways to see that multiplication. Okay, so that is what cross-multiplying is. We have one fraction on each side. We multiply across the equal sign, and we keep the equal sign. So that is cross-multiplication. So a quick note on that. And if, again, anything was too fast, now's the time to pause and rewind. So let's go back to where we were in our example. So in our example, we had this crazy-looking fraction. So what we're going to do is cross-multiply. So we multiply across the equal sign. The challenge is, the trick is, we have to multiply the entire numerator by the denominator on the other side. So we multiply numerators and denominators in their entirety. So I'm multiplying 5 times 4x plus 3. Notice how that is written because that's going to introduce the distributive property. And I've also multiplied the 12 times the 2. So I've cross-multiplied according to that note. So if what I just did was too fast, now's the time again. Pause, rewind. Okay, so I'm just getting some basics covered. From here, I then use the distributive property. 5 times 4x, 20x, 5 times 3, 15. And then I'm back to where I was before, right? If you remember, I'm back to that same spot. I solve for x, right? I undo my 15 by subtracting. I get 9. Then I undo my 20 by dividing. I get 9 over 20. So either way, Remember, there were two different ways we approached this. It doesn't matter which way. We could either clear fractions, or we can simplify first, then cross multiply. It won't matter which way we're approaching these examples. So now that we are done with that note, we can then attack these three problems. And notice it's just for the first example. So we have three different equations, and in each equation we're finding the solution set. Okay, that just basically means solve for x. Okay, so in each example we are solving for x. So we look at example number 1, a good place to begin. So we have 5x over 4 minus 3 over 2 equals 7x over 8, and the whole goal is to solve for x. We want to get rid of these fractions. We can either clear the fractions, or we can simplify first and cross multiply. It won't matter which way. So if I do it one way on the notes, you do it a different way at home and see if our answers can compare. So the first way I'm going to do it is to, how about I simplify first? I think I'll do that. So I'm going to simplify my fractions first. I'm going to simplify the left-hand side because I already have one fraction over here. And remember how cross multiplication works. You want one fraction on each side. Okay, so that's the deal with cross multiplication. So I already have one fraction on the right. Let me get one fraction on the left. So I'm going to simplify each one. I look for a common denominator. Now, I could multiply the first number by 2 over 2 and the second number by 4 over 4. I could do that, but what I'd much rather do is multiply the second number by 2 over 2. Because that would be my common denominator of 4. Okay, so if I multiply this by 2 over 2, I could do that. Now again, if you don't see that, if you can't see that, you can multiply this one by 2 over 2, multiply this one by 4 over 4. We're going to get the same result, I guarantee it. I just like taking the fastest ways out. My first number stays the same. My second number turns into 6 over 4. And then on my equal sign is 7x over 8. Okay, now remember, if I'm going to use simplifying and cross multiplying, I need to have one fraction on each side. Clearly, I don't have one fraction on my left. So now I'm going to keep my denominator and then operate the numerators, 5x minus 6. Okay, so just like the previous unit. And now I have one fraction on each side. And now that I have one fraction on each side, I can cross multiply. Okay, and it doesn't matter which way you're seeing it. As long as you're seeing it correctly, you're going to be good to go. The first thing I see is the 8 times the funky numerator. Okay, so I have an 8 times this funky numerator, 5x minus 6. And then my equal sign stays the same. And now my 4 times the 7x. Okay, so 4 times 7x, of course, is 28x. Now I'm good to go. Right? Now I can just simplify and solve. Okay, so that's what I'm going to do. 8 times 5x is 40x. 8 times minus 6 is minus 48. And that's going to equal 28x. And now there's a bunch of correct things I can do. I have variables on both sides of the equal sign. One of them has to move. I'm going to move my 40x to the other side. I'm just going to take that away. So I subtract 40x on both sides. And then see what kind of magic happens. So on the left-hand side, I'm left with negative 48. On the right-hand side, I have 28 minus 40, which is negative 12. And so I have negative 12x on the right-hand side. Okay? So all I do now is solve for x by dividing both sides by negative 12. And I have x equaling positive 4. And negative over negative is positive. So x equals positive 4. Now, before we circle this, we're going to have to start getting back into the habit of checking answers. Make sure you're checking your answers because there's going to be some crazy stuff happening. I'll talk about it in number 2. So you remember the original equation was 5x. Well, now it's 5 times 4 over 4 minus 3 over 2 equaling 7x, okay, 7 times 4 over 8. Okay, is that going to be true? So we're going to check our answers to see if this works. So we have 20 over 4 minus 3 over 2. Is that going to equal 28 over 8? Well, let's do some simplifying, right? So I've got 20 over 4 minus 6 over 4, same exact change that we've done, equals 28 over 8. 20 minus 6 is 14. So we have 14 over 4 equaling 28 over 8. Now, is that true? Okay, so that's the question. Is that true? If we simplify each fraction, we're going to find out yes, it is true. Because if I divide my second fraction by 1, by 2 over 2, I end up with 14 over 4. Or if I simplify them as simple can be, 7 over 2 equals 7 over 2. Okay, so either way, they're gonna totally work out. Yes, it works. Okay, so we have to get back into the habit of checking our answers. You'll see later. So yes, it works. That means this is our solution set. X equals 4. So check first before saying you're done. Okay, so check first. This one works out. So the solution set for number 1 is 4. That means 4 is the value for x that would make this equation true. All right, so we can simplify or we can clear fractions either way. It doesn't matter. So now we're ready for the craziness that is number 2. Now we're going to start talking about interesting things in a second. So number 2 looks nuts, but again, we can approach it the same way. Right? This is crazy talk, but we can approach it the same way. We've got 2 different methods. We can either simplify or we can clear the fractions. Okay, we can either simplify or clear fractions. And again, what I'm going to do, I think what I would rather do personally, I would rather simplify the left-hand side. This one's already one fraction. The right-hand side is already one fraction. So on the left-hand side, I'm going to simplify first and get myself one fraction there. Okay. Now, how are we going to simplify that fraction? Well, we don't have the same denominator. The denominator on the left is missing a 5. So when I multiply the left-hand number by 1, I'm going to multiply by a clever 1, 5 over 5. That way I'll have the same denominator. If that was confusing, now's the time to hit pause and go back into the previous unit on adding and subtracting rational expressions. Okay, so you want to make sure you're versed on adding and subtracting rational expressions. So now I have my common denominator on the left-hand side, and now I can operate with my common denominator on the left-hand side. Common denominator is 5x. All I need to do is operate the numerator. 30 minus 9. 30 minus 9 is 21, and then minus x. And that would equal 2 over 5. Okay? So some crazy stuff is about to happen. And now what I'm going to do is cross multiply. And when I cross multiply, some stuff is going to get funky. I'm going to start doing things in my head. The first thing I'm going to do is multiply the denominator times the first numerator. I multiply it all the way through. So I'm going to get 5 times 21, or 105, and then minus 5x. I did that in my head. Okay, so if you don't understand, you want to make sure that you are following suit with this. Okay, I'm just doing that in my head. And that's going to equal 5x times 2. And 5x times 2, of course, is 10x. So I have my equation set up. Okay, I have my equation set up. And now I'm ready to solve for x. I have a variable on both sides. So I move one of them. What I'm going to do is I'm going to add 5x to both sides. I think that's going to be easier for me. So I have 105 is going to be equal to 15x. And then I will divide both sides by 15 and see if I get something cool. All right, so if I divide both sides by 15, it turns out 105 divided by 15 happens to be the number 7. Lucky 7. So 7 equals x. Now, before we go and circle this, remember we're going to check first. Now, do you remember domain restrictions? Oh, cats, what are you doing? Don't do this to me. Yes, I'm going to do this to you. So, domain restrictions from challenge 10. Remember that no denominator can equal 0. In case you remember, no denominator can equal 0. So the first thing we have to do is look for domain restrictions before we start circling answers. No denominator can equal 0. So we look at every denominator that we ever had in this problem. So we start at the very beginning. We had denominators with x's in them. So no denominator can equal 0. So what does that mean in this example? Do we have any domain restrictions? The answer is yes. This denominator cannot equal 0, and this denominator cannot equal 0. Therefore, we have a domain restriction, x cannot equal 0. Okay, x cannot equal 0. So that in all of my fractions here, the domain restriction is that x cannot equal 0. If that's a challenge for you, again, you want to hit pause here. Go back to the challenge 10 on function notation, on rational functions and domain restrictions. And make sure you understand, none of these denominators can equal 0. Therefore, x cannot equal 0. Fortunately for us, we're not saying x is 0. We're saying x is 7. Whew! Okay, so we are saying x is 7. Let's plug that in and make sure that no denominators are equaling to 0, and we're going to be good. All right, so when we check our answers, we have 6 over 7 minus 7 plus 9 over 5 times 7. Is that going to equal 2/5? And that's what we're going to work out real quick. Okay, so we have 6 over 7 minus 2 over 35. Does that equal 2/5? So we need a common denominator in the first number, multiply top and the bottom by 5. So 30 over 35 minus 2 over 35. Does that equal 2/5? Well, 30 minus 2 is 28. So 28 over 35, does that equal 2/5? As a matter of fact, it doesn't somehow. That's interesting. So we will divide the numerator and denominator by 7. We end up at 4/5 equaling 2/5. So 7 doesn't work somehow, unless I did something wrong. Let's see if I made a mistake somewhere. Oh, right here. 7 plus 9. I subtracted wrong. 7 plus 9 is 16. 16 here. Oh, good mistake, Mr. Katz. So 30 minus 16 is, what is that, 14. That's much better. So yeah, it does check out. Woo! So you got to be careful when checking your work. I just made a mistake. Hopefully you all caught that. Good mistake. Anyway, it does check out. 2/5 does equal 2/5. So therefore, x does equal 7. Wow. Now you might be thinking, well, Mr. Katz, what if it didn't check out? Let's talk about that in the next example. So you might be thinking, what if it didn't check out? Let's talk about that in that last example. So one more example, and then we'll be done with this lesson. We've got craziness happening here. I'm gonna show you the hard way, and then we'll work on the easy way in a second. Okay. So we have this example. And remember, there are two ways that we can do this. We can either clear the fractions or cross multiply immediately. And so what I'm going to do is cross multiply immediately. Okay, because I already have one fraction here, and I have one fraction here. So let's cross multiply immediately. So if I cross multiply, I have x minus 5 times x plus 3. And then on the other side, I'd have x plus 3 times 2x minus 2. Okay, I'm going to do this the hard way first. So if I have this, what I'm going to do is simplify each side. In the first side, I have x squared plus 3x minus 5x is minus 2x minus 15. On the right-hand side, 2x squared minus 2x plus 6x is plus 4x, and then minus 6. And now what I'm going to do is combine like terms. I'm going to undo things and set it equal to 0, if you remember that. So I'm going to set everything equal to 0. I'll subtract x squared from both sides. And then I'm going to add 2x on both sides. And I'm going to add 15 on both sides. Okay, so those from the previous lesson on solving polynomial equations, right? So my left-hand side will then equal 0. On my right-hand side, I'll have 2x squared minus x squared is x squared. 4x plus 2x is plus 6x. And then negative 6 plus 15 is plus 9. Okay, so I can work it out that way. Now I have my right-hand side. I can factor this. And if you remember factoring, this will be x plus 3 times x plus 3. It's a perfect square, right? And now I set it equal to 0. X plus 3 will equal to 0. Therefore, x equals negative 3. This is the hard way of doing it, right? So let me show you. I'm going to check my answers in a second. That's the hard way of doing it. Let me show you the easy way. I told you there was an easy way. So check this out. There's an easy way to approach this entire thing. If the denominators are the same, what does that mean? If the denominators are the same, because these denominators are the same, what does that mean? That means the numerators must be the same. So check that logical exercise out. If the denominators are the same, that means the numerators must be the same. What? Mr. Katz, that's crazy. Yeah, true. If the denominators are the same, the numerators must be the same. Therefore, my equation could quite have easily been x minus 5 equals 2 times x minus 1. I briefly ignored the denominator to solve for x, right? Because that's a logical operation. If the denominators are the same, the numerators must be the same. So I can see logic, or I don't have to see logic and go crazy. If I do see logic, what would happen? It would be the same thing. Subtract my x on both sides, right? And then I add 2 on both sides. So either way, x would equal negative 3. So it doesn't matter how, okay? It doesn't matter how, x would equal negative 3, okay? So far, so good. I'm not done yet, because what do we got to do? We have to check. Check for what? Check for domain restrictions, okay? So we check for domain restrictions. So we have to look for domain restrictions. Right now we're saying x is equal to negative 3, right? But we check for domain restriction. Is any denominator anywhere equal to 0? So we look at our original expression. We have a denominator. We're saying the denominator is x plus 3. Well, if x plus 3 is our denominator, remember that denominator cannot equal 0. So what we're saying is x plus 3 cannot equal 0. That's the domain restriction. Okay, the domain restriction is that the denominator can't equal 0. Therefore, x plus 3 cannot equal 0. Therefore, x cannot equal negative 3. Okay, so our domain restriction, illegal, is if x was negative 3, right? But when we were solving our equations, x is negative 3. But the domain restriction can't be a negative 3. But our solution says x is negative 3. But the domain restriction says x can be a negative 3. Guess what? Guess what? What does this mean? Even though we're saying x is equal to negative 3, but the restriction is x can't equal negative 3, you know what that means? That means there are no solutions. Because the solution that we're saying is existing can't exist. Therefore, the one solution we found is called, once again, extraneous. Remember that from absolute value equations. So we have an extraneous solution. We said x is equal to negative 3, but x can't equal negative 3. That's an extraneous solution. So what does that mean? That means there are no solutions. There are no solutions to this. No solution. Empty set. Null set. There is no solution to this. So this equation, there is no value for x that would make that a true statement. There are no solutions. So that's the importance of domain restrictions. That's the importance of checking your answers, okay? So that's enough for now. I'm sure we had some exploded heads, but totally do practice this. Make sure you're doing your homework. Practice these examples, and then we'll continue with crazier stuff later.